people who are dwelling in the city. Now, third important point is that sewerage system. Sewerage system, you have smart, you can say sewerage system should be there in the in the city, and there should be provision for recycling the waste, so that you can take the animal in the environment. So that is another. Carbon footprint, can say, should be minimal. So all those things are to be associated with smart.
RTM Nagpur University. Engineering Research Institute, Navy, and the chief scientist and head of
Very good morning to all. Dignitary.
Good afternoon. Good afternoon, everybody. May I request all of you to settle down?
Which do not generate whole building of sustain. So you have to manage your resources ideally and with intelligence.
whether it is water, हे सुरू करून दे, हे सुरू करून दे ना. हे सुरू करून दे. Thank you to Dr. Atul Vaidya, Dr. Manmohan Kalkal, Chair, and Dr. V. Varghese, sir, as a co-chair for your valuable contribution to this conference. We'll now take a short break of 5 minutes. The next session will commence immediately after the break. Kindly ensure you will back and seated on time. Thank you so much. खूप इथे होतं. नाही सांग जाऊ जाऊ सगळ्यांना lunch ला घेऊन जाऊ. आणि नाही. त्यांना बोलायला लाव. त्यांनी ठेवून दिला माहिती म्हणून आपण हा चेअर. ठीक आहे नेक्स्ट याच्या चेअरला सांगतो मॅडम कन्क्लूड कराल तुम्ही. ठीक आहे एंड झाला तुम्ही त्यांच्या याच्यावर जे पण काही पॉइंट्स असतात ना त्याला कन्क्लूड करा. ठीक आहे त्याच्यानंतर मग त्यांनी केलं नाही. हो त्यांनी कन्क्लूड नाही. ऑनलाईन में आवाज आ रहा आवाज ही नहीं आ रहा था.
ऑनलाईनचा आवाज इथे खूप सुंदर येते. ऑनलाईनचा आवाज इथे आवाज जाते का? आपला आवाज नाही चाललाय कारण आपल्याला दोन्ही सिस्टम चालवायचे ऑफलाईन ऑनलाईन. ब्रेक झाल्यावर
कुरवडकर सर आहेत ना ऑनलाईन. कुरवडकर सर ऑनलाईन आहेत का बघ ना प्लीज.
मी सर
आणि आता कुरवडकर सरांचं लाव. ते लाव पटकन ते कीनोट ऍड्रेस कुरवडकर सरांचा.
मी चेक करतो गाडी चालू.
थँक्यू सो मच. ते पेन पेपर घ्या ना कारण ते पॉइंट्स नाही चालत. थँक्यू बाजूला ले जा.
मी इथे आहे मॅडम.
चल कुरवडकर सर
बोला ना तुम्ही.
सुरू करू मी.
तुम्ही इथे माईक कोणता ऑन आहे?
मला नाही हा सुरू कर. ऑन दे.
माईक आहे.
ऑन दे.
हॅलो.
Please be seated. Moving ahead, we are now privileged to have with us another distinguished speaker, Dr. Sudarshan Kurvatkar, professor at California State University, Fullerton, who will be joining us virtually for this online session. The session will be chaired by Dr. N.R. Dhanbe, Dean Academics, KDKCE, as a chair, and Dr. Shilpa Dongre, Professor VNIT Nagpur, as a co-chair. We warmly welcome both of them. I hand over the mic to Dr. N.R. Dhamge to begin the session.
Good afternoon. Welcome to this session. Session 2. The session keynote address is delivered by Dr. Sudarshan Kurvatkar, the professor at California State University, Fullerton. I welcome you, sir. You are delivering this keynote address from your university from USA. So I hope
अरे यार मला नाही
we welcome you and it's a flawless welcome. So welcome you sir for this international conference.
Well, good afternoon, everybody. Can you hear me?
Yes, sir, we can hear you. And
Okay.
I
Um,
now Dr. P. Vaidya sir to give the introduction of Dr. Sudarshan Kurwadkar sir.
It is my pleasure to introduce Dr. Sudarshan Kurwadkar to the audience. Dr. Sudarshan Kurwadkar received his MS in Civil Engineering from Indian Institute of Technology, New Delhi. He obtained his doctorate in Civil Engineering in Environmental Engineering Synthesizes from Missouri University of Science and Technology, USA, formerly University of Missouri in Florida. Immediately upon graduation, he joined the Missouri Department of Natural Resources as an environmental engineer and worked for 4 years. In 2009, he joined Dallas State University of the Texas A&M University System as an assistant professor in the Department of Civil Engineering and Computer Science. Some of his major achievements include receiving a Teaching Excellence Award from the Texas A&M University System, Early Career Award from the American Society of Engineering Education, and recognition of Sigma Xi, 125 Fresh Faces of Sigma Xi. Dr. Kurwadkar is a board certified environmental engineer and a licensed professional engineer. His research interests are in the broadly defined area of physical and chemical processes in the environmental engineering. Dr. Sudarshan Kurwadkar joined California State University in Filtron as an assistant professor and currently he is working as a professor of civil and environmental engineering at the state California State University in Filtron, USA. Thank you.
Thank you so much, Vaidya sir. It is a very honor for one of us, sir. So you have joined from US and I know it was night at there and US is a night time. So it is very nice of you to deliver this address for the today's international conference. Welcome, sir. Please go ahead.
well, thank you very much for this opportunity to deliver this keynote address at the International Conference on Next Generation Infrastructure, Green Technologies, Smart Cities. It's midnight here in California and 3 a.m. in Ohio, basically 3 a.m. in the morning in New York, essentially. So we have 3 hour difference. So, but this is midnight, and so obviously the conference is focusing on the next generation of infrastructure and green technologies and smart cities. But at the same time, I think it is important that we also take a look at the emerging contaminant of concern. Our the changes brought out because of our changing lifestyle preferences and what you have. We have beset with several problems in terms of environmental pollution or pollution in different environmental matrices, including air, soil, water, groundwater, and what you have. So in this presentation, basically, I'm going to deliberate on two of the emerging contaminant of concern. Means not so much of emerging contaminant of concern. These pollutants were present there, but their impact and their detection is now becoming more common and routinized. So with that said, I'm going to talk about contaminants of emerging concern, environmental occurrence, fate, and transport. So in this presentation, basically, I'm going to talk about per and polyfluoroalkyl substances and pharmaceuticals and personal care products. And how these contaminants basically behave in means during the extreme climatic conditions, maybe extreme flooding or extreme drought. how does these changing climatic conditions affect the freight and transport of some of these emerging contaminant of concern, or for that matter, why we at all even bother about thinking about these contaminants? One of the aspect during our research on this environmental contaminant of emerging concern, we noticed that there are widespread disparities between the population that is being exposed to the pollutants. So, for example, I'm from California. So in California itself, I'm 40 minutes from Los Angeles, okay, Hollywood. So people living in Beverly Hills may not necessarily drink the same water that people living elsewhere in California. So there is that environmental inequities. And what we did is we looked into the pollution, the occurrence of these emerging contaminant of concern, and then we zeroed it onto the geolocations, and then we conducted some demographic analysis. Who are these people that are being exposed to these contaminants through ingestion of contaminated drinking water? So those are some of the findings I'm going to share with you. This is not yet published, but we intend to publish it very soon. Very important definition is contaminant of emerging concern. When we use this word CECs, what it means, they are of emerging concern means were they not been a concern in the past? That's not really true. Okay. These contaminants were present in the environment, but we were not monitoring for them. Maybe because we did not have the analytical capability to detect them at that level. The level we are looking at is parts per trillion. Okay. But one thing is clear that these contaminants have a potential to cause adverse impact even at that nanogram per liter level. So these are highly bioactive compounds, and they have been present in the environment, like for example, per and polyfluoroalkyl substances have been in use since 1940s, but only recently, even I would like to go on to say that only by 2010 or 2020 for that matter, the United States Environmental Protection Agency has revised the analytical quantitation protocol for these compounds. So our ability to understand, detect, and quantify the occurrence of these compounds is what we kind of colloquially calling it the contaminants of emerging concern. Okay. So it's not something new. It is that these contaminants were present there. It just their risk is becoming apparent only recently. So initially I thought of talking about per and polyfluoroalkyl substances, pharmaceuticals and personal care products, and a subset of kind of insecticide family, neonicotinoid group of insecticides. Between I think 2015 and 2020, you can give and take. Neonicotinoids were highly discussed in the media because of their implication to honeybees. I mean, the neonicotinoid insecticides were implicated in colony collapse disorder. And so that was a huge topic, and this has led to the banning of these neonicotinoids in the environment. Use of neonicotinoids were banned for use in vineyards and citrus orchards and what you have. All right, so what is per and polyfluoroalkyl substances? Okay, these are the routinely called PFAS or forever chemicals. Forever because they are recalcitrant, they are persistent, they are non-degradable under biotic or abiotic conditions. Okay, so they just linger in the environment for really foreseeable future. Okay, so PFAS are resistant to grease, oil, and water even. The carbon fluorine bond is one of the strongest bond that is out there, which renders these compounds practically non-degradable. Okay, so that's the reason they persist. So they are resistant to both abiotic and biotic degradation. They are soluble. They were introduced back in the 30s, but commercial applications were kind of found in late 40s and what you have. There are nearly 1,040 consumer products, including your commercial and household items that contains these substances, per and polyfluoroalkyl substances. In fact, the clothing that I'm wearing right now, these textiles have PFAS on them. So they are used in myriads of application, including cosmetics, textiles, semiconductors. One of the major use of per and polyfluoroalkyl substances is their use in firefighting operations, typically called aqueous film forming foams, AFFF. So I think a lot of these military operations, firefighting operations, they use tremendous amount of AFFS, aqueous film forming foams, and I mean several these compounds are detected on several military installations, Air Force bases in the United States. So because of the versatility of these compounds, PFAS, these are found in every nook and corner of our consumer product, including chocolate wrappers, food packaging, and what you have. Let me give you one of the most common example where these compounds are used. If you have used a non-stick cookware, okay, non-stick cookwares are typically coated with PFAS. Okay, so if you had your omelette or scrambled eggs or even chapatis for that matter, chances are you have been exposed to PFAS. Okay, so that's one of the most common use. Currently, some of the cosmetics, including mascara, has residues of PFAS in them. PFAS is in food items. So these are some of the different food items that are listed here. You have pineapple, catfish, shrimp, baked salmon, turkey, tilapia, iced chocolate cakes, all of these. So they are everywhere, not only in the consumer products, but also in food packaging, food products also. So even though these compounds were in use since the 30s and 40s, not much has been done. And nobody bothered about them, until 2010, the research about these compounds were restricted to very few research laboratories. It was not commonplace. In fact, it was only in 2022, Miss 2020, June 2020, the United States Environmental Protection Agency issued the final protocol for detection of these compounds called method 537.1 using liquid chromatography and mass spec. So it's not this long time ago, it's just few years ago, this 2020, just 5 years ago. So lately, I mean, I would encourage, if at all, if you are on your phone, you can Google it, PFAS in the news, and you will find everything about PFAS, how the world is dealing with it, how the world is, basically the water utilities dealing with the PFAS, so on and so forth. Even if you are looking at the health-based advisories, those were in place since I believe 2007 or 14, something like that, until 2016. They were set at around 17 nanogram per liter, 70 parts per trillion. Here are some of the sources and pathways right from your industrial to consumer product, including your water and wastewater and everything in between. You can get exposed to the per and polyfluoroalkyl substances. In fact, in the United States, there is no pure blood as of today. Okay. So the I think the National Institute of Health or someone was searching for a pure sample of blood and they couldn't find it in the existing American population. So they resorted to the old preserved sample and they find one in a sample of a soldier that fought during the Second World War. So you can imagine that these compounds are in our blood, bone, and marrow, and every place else. How about environment? So in surface water, biosolids, soils, and groundwater, there are different levels of these compounds were detected. Okay. So you can see that 2.7 nanogram parts per trillion, okay, nanogram per liter, all the way to 420 nanogram. Basically, you can call it 420 microgram per liter. So that's quite a huge concentration in surface water bodies. Then we have biosolids and wastewater. Then we have soils and then groundwater. So this is the map of the United States. You can see that it is pretty much dotted everywhere. And this part is California. We have this whole big coastal line. We share the Pacific Ocean, and the Atlantic Ocean is this way. So you can see that this is kind of northern United States. So all your New York, New Hampshire, Vermont, Maine, all of these places, including Washington, D.C. and all. This is specific to California. 21,400 facilities investigated, and 12,000 of those facilities are in California. Now, you may be wondering why California only. Okay, you have to understand that economy-wise or industry-wise, including agriculture, okay, California ranks number 4th in the world in terms of economy. If California would have been a country, it's the 4th largest economy. So the reason why I'm sharing this information is that you can put this information in perspective and hopefully able to derive some information about the likelihood of contamination. Okay. So in the state of California, we have detected like military base, we have 9 sites, groundwater 23 sites, and municipal drinking water 162 sites. With these two contaminants, per and polyfluoroalkyl substances, PFAS like PFOA and PFAS. This is octanoic acid and this is octanoic sulfonate. So now if I show you the health-based advisory level or the threshold, in India, we have Bureau of Indian Standard. In the United States, we have MCL, maximum contaminant level. Okay, and those levels are set up at, let me share with you if I can. Those levels are set up at here. 4 parts per trillion for PFOA, 4 parts per trillion for PFAS. Now you may wondering like when these things happen. This is in March 2024, just last year. Prior to that one, there were no regulatory guidelines or what you have. So if you look at the drinking water facilities, 7.3 to 650 nanogram per liter. Groundwater at military bases, 891,000 nanogram per liter. So municipal drinking. So you can see that. So approximately 146 public water systems that serve nearly 16 million of Californians exceeds those regulatory threshold. This is the nationwide studies. Uncontaminated monitoring rule 5. That is, these are the average result for PFAS in January 2025. You can see that the public water system that are serving more than 10,000 people have one or more averages greater than the regulatory threshold, greater than the MCL. So, and these are some of the sites that talks about occurrence of PFAS, military bases, and the various installations that have shown the positive presence of PFAS and PFOA in the United States. In India, so these are the prevalence of per and polyfluoroalkyl substances in India. Now, don't be surprised that it may look like this, but again, I think the sampling and analysis had just begun. So don't think that these are the only places. There will be more places as as the samples will be analyzed across the length and breadth of India. Okay. This is very recent study published in 2024 that shows the presence of PFAS in water, sediments, and atmosphere and biotas. So this is basically, I will not even call it a baseline study, but the work has already started. So down the lane, this map will be kind of all dotted everywhere. These are some of the regions in Asia, Africa, and Europe. So this is Europe, this is Africa, and this is part of Asia there. So the symbol shows you the different levels of PFOA and PFAS in the different part of the world. So because of the versatility of these compounds, they are used in every industrial consumer products. And so it's no surprise that many locations in the Americas, Europe, Asia, they are routinely detected. So we understand that the water resources are contaminated. We understand that there is wide variation in concentration, even within the media and across media, even within water means, and then between water and groundwater, surface water, soil. So what is the concern? Are there any human health concern that we should be worried about? Well, guess what? PFAS and PFOA both are known carcinogens. Okay. In fact, PFAS is implicated in developmental toxicity, the formation of the fetus. Okay. If the mother's blood is contaminated with these compounds, then it will be transferred to the fetus and to the baby through milk. So now imagine that if these compounds are non-carcinogen, okay, any exposure, when we determine the risk, the chronic daily intake is based off of your body weight. So imagine like a 3-4 kg infant is being exposed to these type of compounds. Okay. So that's why back in 2017, this is all California studies. Okay. So PFAS have been known to cause reproductive toxicity. So this is basically the carcinogen right now. So you can see that these are the different routes and exposure pathways: ingestion of PFAS contaminated drinking water. Then we have inhalation and dermal exposure. Increased risk of diabetes, reduced fetal growth, thyroid, breast cancer, testicular cancer, behavioral issues, so on and so forth. So that's why when I mentioned that if you have a time, you can Google it and search right now that PFAS are even today is being discussed. So very dangerous. So These are some of the documented studies, sometimes they call C8 studies. And as you can understand that toxicological profile of PFAS have been kind of underway for a very long time. So this is back in, I think, back in 2000, they conducted C8 studies, and these are some of the findings about different diseases that are attributed to the exposure to PFAS. So you have heart disease, autoimmune disease, thyroid disease, and then pregnancy-induced hypertension and preeclampsia. So what we are doing it? Well, here is a map of the United States again. These colors show some of the enacted laws, proposed bills, and there are no regulations where there are no coloring. So you can imagine like large number of products, consumer products are still not regulated, especially those products that contain per and polyfluoroalkyl substances. So California Environmental Protection Agency, they came up with their own regulatory guidance, 0.997 ppt for PFOA and 1 ppt for PFAS. Beginning January 2025, it is illegal for anybody to manufacture, distribute, and sell anything that contains PFAS in the state of California. I mean, I would like to emphasize that all regulations in the United States starts with California, and everybody else copied after that one. So March 2020, July 2022, EPA finalized the lifetime health advisory for PFOA at 0.004 parts per trillion and 0.02 parts per trillion for PFAS. So you can imagine 1 parts per trillion means a drop in the Olympic size pool, 20 Olympic size pools basically. So this is announcement on March 2024 when the United States promulgated the National Primary Drinking Water Standard. And those are like for PFOA, it is 4 ppt. And these are some of the other PFAS which are non-carcinogen. So here are the all things. So PFOA and PFAS, you have MCl at 4 parts per trillion. And hexane sulfonate is 10 ppt. Then you have Genex, these are dimers. These are 10 ppt. So for these compounds, like these 4 of those one, we have hazard index. Okay, so we established the hazard index for these ones, and for these first 2 ones, we have the risk, carcinogenic risk. So carcinogenic risk, if it is greater than 1 into 10 to the power minus 6, that is 1 in a million, then we can say that it is going to cause adverse impact. Basically, incremental lifetime cancer risk exists if it is exceeds the 1 in a million threshold. But for hazard index, which is a non-carcinogenic risk characterization, if the hazard index is greater than 1, then yes, either individually or collectively. It means all of these compounds may have the hazard index of less than 1, like 0.8, 0.6, everything is less than 1, but cumulatively, if you add them all and if it exceeds 1, then there is a possibility of adverse health impact. So this is how we calculated the hazard index. And this is chronic daily intake using the EPA formula. And then we calculated the incremental lifetime cancer risk for 2 of the compounds. So these are some of the results, incidence of non-carcinogenic risk. So Los Angeles have 8 groundwater subbasins. Orange County, where I live, has 91 subbasins. Sacramento 3. And so these are different groundwater subbasins that shows the presence of PFAS at a level that their non-carcinogenic risk exceeds the threshold of 1. So these are the left-hand side shows the map and the scale. I'm not sure whether it is really visible for you. And this is a little bit color coded, but these are the maps. These are the original studies, original findings of different hazard indices throughout the state of California. Left map shows the non-carcinogenic risk, and the right map shows the carcinogenic risk. I mean, apparently it looks like majority of the risk is basically below 10 to the power minus 6 threshold. But then you have to understand that we are looking at only one exposure pathways, that is ingestion of drinking water. And this is also for the exposure is an adult scenario, so, but there are other avenues for exposure to these compounds. So the likelihood of risk being higher is very high. Because guess what? If a person not only drinks this water, but uses all kinds of consumer products, including makeup, mascara, the wrinkle-free clothes, grease-proof clothing, water-resistant clothing. So there are different routes and exposure pathways through which additional chronic daily intake might go up. So what you are seeing here is super conservative, very lowest of the possible risk map. These are different regions being compared. Southern California versus Northern California for non-carcinogenic risks. And this is specifically the Los Angeles metropolitan area. I would like to bring it to your attention that this is the first ever study that is conducted across the state of California. This is the first ever study. Again, we are just looking at one exposure pathways. Okay, there are multiple exposure pathways. So whatever you are seeing right now is just a baseline risk. The only message I would like to say that the risk exists. Let's means we can say it safely that yes, there is an imminent danger of ingesting PFAS contaminated water. So this is the risk for comparative risk for carcinogen between Northern California and Southern California. So I'm not sure how visible the map is, but you can see on the left hand side there is the menu. I mean the what do you call the identifiers that are used for this map, heat generated map. This is specifically for Los Angeles metropolitan area. So not only California is banning these compounds, now it is ban the use of these compounds in textile also. Please note that the states and federal government, they are banning these compounds, their use, sell, manufacturing processes, they are being banned, but also these compounds are voluntarily phased out. So we are not looking at something new here. We are essentially looking at the legacy contaminants. So what we are doing here, then we are planning to remove these compounds, and one of the safest technologies that are out there is the activated carbon. Basically, that's a foolproof, and a lot of water utilities in within Orange County and elsewhere, they have resorted to use the carbon adsorption beds for removing of these compounds from drinking water. So as I mentioned, I've showed you how to how we calculated the hazard index and the risk. And so you can see that these are the different populations, okay, that are being exposed in the different parts of the state. So this is all about PFAS. I don't think I'm going to talk about pharmaceuticals, but I will give you the cursory idea about their occurrence and detection in water and wastewater matrices. So pharmaceutical and personal care product. Pharmaceuticals, the one that we use when we are sick or have disease or infection and what you have. So those are pharmaceutical. Personal care products is more like hygienic product, your makeup, your hand sanitizer, hand washed lotion, so on and so forth, shampoo, soap. Those are all personal care product. Now, some of these personal care products also equally are dangerous, and they are routinely detected in various environmental matrices. So yes, there are major classes that are used both in human therapy as well as in animal therapy. So in human therapy, we use it for combating the disease, fighting the disease, and preventing the onslaught of infectious diseases, opportunistic infection, and what you have. Typically, in human therapy, we use a therapeutic dose, recommended therapeutic dose. Not so much in animal agriculture, though. So, I mean, this is not a common problem in India, but I think I'm sure some of the poultry production in India is also based off of use of these compounds, pharmaceuticals. In the United States, large number of pharmaceuticals are used in animal agriculture than in human therapy. This is a kind of comparison between the net use of antibiotics and pharmacies, different types of pharmacies in animal agriculture and human therapy. Now, why we are comparing this one? The reason we are comparing this because the commonality of antibiotics in human and animal therapy may engender the growth of antibiotic resistant microbes. So for example, if the microorganisms are resistant to antibiotics used in animal therapy, they will as well be resistant to antibiotics used in human therapy. These are some of the FET mechanism, like once administered, where they go. So it goes through your gastrointestinal tract, then to the kidneys and to the liver. So out of 100 units, nearly 40 to 70% get excreted back into the environment. So our body does not metabolize the 100% dose. And so once they are flushed out in the environment, so this is in human therapy. In animal therapy, nearly 90% of these antibiotics are get excreted back into the environment. Now, there is a very funny story regarding how and when and why we uh, come to rely on the pharmaceuticals for animal agriculture. I think back in 60s, somebody accidentally fed the chicken with tetracyclines. In the accelerated growth of chicken, they witnessed it after using that subtherapeutic dose led to the widespread use of antibiotics. So it's always a subtherapeutic dose. What is mean by that? Like if the therapeutic dose is like 40 milligram, let's say, subtherapeutic dose could be 1 milligram, even 2 milligram. So it's just very low concentration, but it fattens the animal, the fattens the chicken and what you have. So yes, there are ecological consequences. It will disturb the ecology. It may breed antibiotic resistant microorganisms, and so basically it disturbs the biota upon chronic exposure, not one time exposure, but chronic exposure. Again, 62% of the antibiotics given to animals were medically important to humans. So you can see that they are used in dairy farms, pig farms, chicken farms, and what you have. Now, not necessarily all of these get excreted back into the environment. They may remain localized. So before they slaughter the animal, there is what they call weaning period or what you have. So for a few days, the animals are kind of stored separately just to kind of get rid of those antibiotics. So the World Health Organization said that the development of antimicrobial resistance is one of the 10 threats to health with the potential to become a global epidemic. We just have experienced a pandemic, but this is something that is likely to happen is the epidemic of antibiotic resistant microbes. So here is a little bit of sobering news. The 46 million Americans, so 46 million, give and take 50 million. 50 million out of roughly 300 million or 350 million. So like 1/7, like, yeah, 350, so 50, so 1/7. So one person in every seventh person is essentially exposed to the pharmaceuticals. That's how commonplace it is. So what did we do? We analyzed the occurrence, the presence of these compounds in two of the major wastewater treatment plants in Southern California. And the uniqueness of these plants is that they have two different secondary biological treatment processes. One is trickling filter and another one is activated sludge treatment. So this is a kind of layout essentially. So grid chamber, you have primary clarifier, primary sedimentation basin. So we collected the sample at every step of the way. The idea is we are looking at the sequential removal of these compounds. So the moment wastewater exits the grid chamber, we are looking at, did it remove anything? Is the grid chamber is an effective technology for removal of? If not, then did the primary clarifier remove it? Did the trickling filter remove it, or activated sludge removed it? So we looked very granular analysis conducted over 1 year period. So we analyzed nearly 30 samples, 30 pharmaceutical compounds. This is another plant. This is a scaled version. We already talked about it. 1 nanogram per liter is basically 1 parts per trillion. And this is EPA threshold, very close to 0. All right. This is the method detection limits and what you have. This is the analytical protocol. The detection was carried out using gradient separation technique. You can see that the gradient is changing from mobile phase A at 98% A at 0 to by 25 by 13 minutes it's 0 0, and mobile phase B is basically 100%. But then again it ramped back to mobile phase A by between 16 and 25 minutes. So these are the different operating conditions. This is a column C18 Agilent Zorbax Eclipse column. So these are the different method detection limits for all these compounds, and method reporting limits, calibration range, and what you have. So some of the mechanisms that are likely to be experienced by these pharmaceuticals include sorption, photolysis, volatilization, biodegradation. So basically, these are heavier compounds. They don't necessarily volatilize, So one of the mechanism could be essentially sorption onto the biosolids, not so much volatilization and not so much biodegradation. So here is one quick look at different pharmaceuticals and as a function of solubility. So this triangle shows the decreasing solubility and the primary treatment. So you can see the carbamazepine, an analgesic drug. You can see that it is completely not removed. It is 0% is removed. Whereas hormonal product like 17-beta estradiol is removed 25%. And Glaxolide, I don't know what is that, but it is 90% removed. Similarly, but this tells you about the decrease in solubility. So this galaxolide is less soluble. Okay, so that's why it got removed. Maybe sorbed down to the solids material. Whereas carbamazepine has higher solubility, and you can see that it just got out of the primary treatment. In secondary treatment, a little bit of more removal occur. Okay, you can see that the same compounds, like 70 units, so basically 30 units. I mean, these are hypothetical scenarios. The idea is we are just showing that how does the secondary treatment works when we have compounds with different solubility. So these are the snapshot of results. You can see that some of these compounds have the concentration less than 100 nanogram per liter. Then we have 150 to 718, 1300 to 7000. So these are the different ranges. And these are the different compounds with their respective rate, removal rate. We have conducted, reported from the literature as well as from our own study. You can see that. So we group these compounds into hormone, analgesic or anti-inflammatory, antibiotics, macrolides, and what you have. And this is the kind of group study that talks about the seasonal variation and removal across different treatment regimes: primary treatment, tertiary, trickling filter, activated sludge, and final effluent across different seasons: fall, spring, summer, and winter. Okay, so these are the different studies that tells you how our study compares with theirs. These are some of the key findings, like 28 of 30 analytes were detected in all surveys. So they are everywhere. Activated sludge treatment is better for some of the compounds, like these diclofenac kind of analgesic, mostly for analgesic and for some antibiotics, sulfamethoxazole. So not a whole lot of variation, except for some of these compounds like oxybenzone, which is sunscreen lotion that you can expect to be kind of higher in concentration during summer. All right, mitigation. FDA has banned some of these compounds, carbadox from animal agriculture. Again, triclosan, that's typically used in hand wash lotion, is also banned. There is active way of collecting the drugs, unused medication. Instead of throwing, people are encouraged to give it back. And so these are the places where you can take your drug, pharmaceuticals, and what you have. Okay, so this is the last slide, how the climate change in impacting the contaminant freight and transport. So climate impact, basically rise in temperature, sea levels, and snowpack, and what your heavy precipitation or drought. So these are the things that are happening in California, essentially. Okay, temperature is warming and very high confidence level. So this is all. I'm not going to talk about climate and weather. This is pretty means common sense, I believe. So, but yeah, what is going to happen because of the extreme climatic events, erratic monsoon, you can get extreme weather events. During drought condition, you can experience depletion of ground level. Obviously, during flooding, you can as well experience the groundwater recharge, temperature rise, sea level rise, and what you have. This is recent wildfires. This is where I live, that blue dot, and elsewhere, these are the fires that were these were attributed to maybe increased temperature. Water demand, again, because of the growth in water demand with vis-a-vis population, there is increased emphasis on maintaining the water resources. So any pollution, maybe because of the PFAS or pharmaceuticals, is a grave concern. So you can see that these are the different cities that shows the water scarcity across the world, some with perennial and some with seasonal. Seasonal in the sense the water scarcity is far more evidence in certain season, whereas perennial means perpetual. Day zero, probably you are familiar with this news. Day zero means there was no drinking water in Cape Town, South Africa. So how we can assure the water security in the event of extreme climatic events? So unconfined aquifer will be far more prone to pollution, especially if there is a tidal surge, and so the water table can fluctuate accordingly. Extreme precipitation also lead to delocalization because of the groundwater recharge, and it will demobilize, delocalize the contaminant, making it challenging to delineate the extent of contamination, because now you are looking at the moving target, Abrupt surge in contaminant mass, if you have a remediation treatment in place, it will not work as per plan because the abrupt changes. This is the slide that is kind of pictographic depiction of how typical PFAS move. And this is how your remediation system has to adapt to changing climatic condition or extreme event. The remediation technology has to be resilient, and it quickly adapt to the extreme climatic conditions. And so this is a very telling slide, like potential changes like power interruption, physical damage, water damage, reduced access. So all of this is a very good thing. Again, even in terms of remediation, there are ways to kind of expedite the remediation protocol, and modern tools such as Internet of Things, quantum computing, machine learning, artificial intelligence-based tools can help us expedite the remediation. We recently published a perspective on application of density functional theory, documenting how we can expedite the groundwater remediation. Again, in situ processes will become more vulnerable to extreme climatic conditions. So yeah, these are some of the challenges. Aquifer storage and recharge, micropollutants may become delocalized and contaminate a larger portion of the water resources. So some of this technology that are out there, high resolution site characterization, real-time sensor monitoring. So a lot of these technologies out there that we can use to prevent water pollution. So there are some of the water management technologies. System adaptation, again, you have to ensure that your water treatment system is compatible and adapting to the changing conditions, and the water quality, drinking water quality at least, is not compromised. Storage recharge, there are some efforts in the state of Texas and in California to use the wastewater as a source of drinking water, essentially what we call as a direct potable reuse. So there is an emphasis right now currently underway in California and Texas that you can drink the treated wastewater. Smart water grid is an essential attribute of smart structure. This is smart infrastructure. So basically the distribution and maintenance, you can employ some of these modern tools, Internet of Things and sensor-based technologies, and create a smart water grid. Groundwater replenishment system. Right now we are doing artificial recharge. We can as well do the direct potable reuse. Rain barrels, rain gardens, you can use that one. These approaches are consistent with the modern infrastructure. In conclusion, we have several stressors. Population is one of those one. There are obviously disparities between the rich and the poor people in terms of the burden they carry, the disproportionate burden the poor and economically disadvantaged community bear due to the environmental pollution. And then there is this climate change that your system has to adapt to the emerging climate challenges. With that said, these are some of the contributors to this presentation: Everardo Chavez, Emma Hoffman Davis, Riley Christie, and Alexis Ortiz. Well, I will take your questions now. So if you're having any question, please let me know. It's almost 1 a.m. here in California, and it's time for me to go to bed, but I will entertain few questions. Thank you.
Thank you.
Your voice is not clear. There is an echo. I can't hear anything clearly.
Okay, sir.
Yeah, now is still echo is there.
Hello.
Yes.
Yeah, now it is clear, sir.
Yes, a little bit. There is still
Yeah.
a background echo. Yes.
Okay. Yeah. Thank you so much, sir. I really appreciate you for this wonderful lecture at this time of night, 1 a.m. at your place. So we
Yes.
really appreciate your efforts, sir. Thank you so much. You talked on the topic of contaminants of emerging concern, environmental occurrence, fate, and transport.
Yes, ma'am.
We really appreciate about the contaminants that you talk about, and we got to know about how these contaminants are affecting the human life. About we are using them in cosmetics, food items, and your study on PFOS and PFOS. Both were really appreciable. The studies were very detailed, and I hope California is leading way to the world that how to ban these contaminants. So we really appreciate you, sir. And in this session with me is Dr. Shilpa Dongre. You know her, sir.
Yes, ma'am.
She's at VNIT. So
Yes.
we really appreciate all of you. All of us really appreciate you for this wonderful session, sir. There is no question in the chat box. It was wonderfully explained. Thank you so. Thank you so much. Yes, sir. So there is one question.
Yes.
Yeah.
Hello, sir.
Hello.
I'm Janvi Patil, an MTech student. My question is regarding the PFAS analysis using chromatography. What are the key trade-offs in sensitivity and selectivity when choosing different MSMS detection methods for wide range of PFAS compounds?
Excellent question. One of the important things about detecting these compounds, and the sensitivity, you have to understand that these compounds. Okay, are you familiar with the fluidics of the LCMS system? The fluidic module that convey the mobile phase and the sample, the carrier line. Are you
Yes, sir.
familiar? So because these compounds, if you have a regular LCMS, and if you are analyzing these compounds, it will stick to the tubings continuously and it will continue to bleed. So you can always see the ghost peaks. Okay.
Okay, sir.
So you have to retrofit the the entire fluidic module. Okay. For all of these PFAS compound. I mentioned, hold on a second. Regarding the sensitivity, we are, okay, your method detection limit has to be at least below, where is this one? Can you see my presentation?
Yes, sir.
Okay, let me see. I'm scrolling it. I'm not sure whether you can see it, but let me see. Here it is. Oh, that's pharmaceuticals. Okay, hold on. Okay, it is this one, I believe. Okay, so this is method 537.1. Okay, do you have access to this one?
No, sir.
Okay, let me share it in the chat box so that you can have it there and you can find everything you ever wanted to know about the analytical quantitation of PFAS, sensitivity, and what you have. This is the latest and the greatest. Okay, let me, here is, I'm putting it in the, okay, just a second, it's downloading, I believe. Oh, damn it, this is, okay. Give me 1 minute, I will put it in the chat box because I'm not sure whether this is available there. Okay, PDF, okay, all right. Oh gosh, give me one. Oh gee, this is just a PDF downloader, damn it. Give me 1 second, I'll share with you the whole document, then you can have it. Let me go back here, okay. 537.1, here is everything you ever wanted to know. Okay. So I'm sharing this document in the chat box. Okay.
Yes, sir.
Yeah, so you can open it and see it for yourself. This is the latest and the greatest version of the method, but that's an extra. Are you a chemist by any chance?
Sorry?
Are you an analytical chemist?
No, sir.
Okay, do you run HPLC?
Sir, I'm a student for structural engineering, but I have interest in chemistry and chemical engineering as well.
No. This question pertains to the analytical quantitation and sensitivity of the instrument. Okay.
Yes, sir.
And
I have read some documents related to it.
Oh, okay,
Course.
okay. But let me share it so you can, okay, this is your chart box so you can see the document. Oh, hello. There is no way I can attach the document in the chart box. What is this format? Oh, gee. Oh, gee. Is there a way to?
So maybe I can mail you the question.
No. I mean, I got your question, like how sensitive, what is the
No, sir, we can
sensitivity
talk.
of the equipment? Your sensitivity of your MS system and LC system depends on who is the manufacturer. Like if Agilent is making that LC system, has a different sensitivity. Waters has different sensitivity. Dionex has different sensitivity. So again, it varies. Again, I mean, the type of column, operating conditions, 1,000 things are there, you know. But what I'm going to share with you is, let me see if I can put it in here. Oh yeah, okay. You got it? It's in the chart box right now.
Yes, sir.
That's a PDF, so you can read everything you ever wanted to know about the analytical quantitation. But again, remember that not two methods are same, not two instruments are same, and so their sensitivity will vary. So in this one, you can find everything. It means the
Thank you
QA,
so much, sir, for sharing that document with our participants. We
Yes.
extend our heartfelt thanks to our keynote addressee, Dr. Sudarshan Kurvatkar, for his time, effort, and valuable keynote address. We would like to extend our sincere gratitude to Dr. N.R. Thamge and Dr. Shilpa Dongre for leading this session as the chair and co-chair for this session. Thank you so much once again. Dear
Thank you very much.
participant, thank you, sir.
Thank you.
Dear participants, we would like to inform our offline attendees that lunch has been arranged at lunch venue. Please feel free to head there and join us for lunch. We kindly request you to reach by 2 p.m. as we will resume with another glorifying keynote addresses by Dr. Manmohan Kalgal, past president of ICI, Dr. Putul Haldar, IIT Roper, and Dr. Simon Kleinberg from Denmark. Everyone must join the session at 2 p.m. sharp. Thank you so much.
Thank you.
ये अटल शक्तिमान है, सूर्य की चमकान है, ये नींव है जुनून का, करोड़ों अरमान है। प्रगति की ये राह है, इंडिया की नई सुबह है। ये चक्र है सिद्धांत का, अल्ट्राटेक गवाह है। समुद्र भी झुका जहां, झुका भी आसमान है। पाताल विजय भव, यही तो हिंदुस्तान है। कदम कदम की साज है, एकता की यह आवाज है। वो लौह का आशीष था, भारत को जिस पे नाज है। ख्वाबों की इमारत है, वो ख्वाब अब हकीकत है। प्रतिज्ञा है हमारी ये, और बढ़ता जाता भारत है। ये देश की पुकार है, ये प्रगति का त्योहार है। शिखर तक की राह पर अल्ट्राटेक का ये प्रहार है। बार 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 है, सिर्फ जीत ही जीत ना हार है, क्योंकि यह अल्ट्राटेक परिवार है। ये अटल शक्तिमान है, सूर्य की चमकान है। ये नींव है जुनून का, करोड़ों अरमान है। प्रगति की ये राह है, इंडिया की नई सुबह है। ये चक्र है सिद्धांत का, अल्ट्राटेक गवाह है। समुद्र भी झुका जहां, झुका भी आसमान है। पाताल विजय भव, यही तो हिंदुस्तान है। कदम कदम की साज है, एकता की यह आवाज है। वो लौह का आशीष था, भारत को जिस पे नाज है। ख्वाबों की इमारत है, वो ख्वाब अब हकीकत है। प्रतिज्ञा है हमारी ये, और बढ़ता जाता भारत है। ये देश की पुकार है, ये प्रगति का त्योहार है। शिखर तक की राह पर अल्ट्राटेक का ये प्रहार है। बार 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 है, सिर्फ जीत ही जीत ना हार है, क्योंकि यह अल्ट्राटेक परिवार है। ये अटल शक्तिमान है, सूर्य की चमकान है, ये नींव है जुनून का, करोड़ों अरमान है। प्रगति की ये राह है, इंडिया की नई सुबह है। ये चक्र है सिद्धांत का, अल्ट्राटेक गवाह है। समुद्र भी झुका जहां, झुका भी आसमान है। पाताल विजय भव, यही तो हिंदुस्तान है। कदम कदम की साज है, एकता की यह आवाज है। वो लौह का आशीष था, भारत को जिस पे नाज है। ख्वाबों की इमारत है, वो ख्वाब अब हकीकत है। प्रतिज्ञा है हमारी ये, और बढ़ता जाता भारत है। ये देश की पुकार है, ये प्रगति का त्योहार है। शिखर तक की राह पर अल्ट्राटेक का ये प्रहार है। बार 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 है, सिर्फ जीत ही जीत ना हार है, क्योंकि यह अल्ट्राटेक परिवार है। ये अटल शक्तिमान है, सूर्य की चमकान है, ये नींव है जुनून। ये अटल शक्तिमान है।
Good afternoon, everyone. I hope you had a lunch and are feeling refreshed. We now reconvene for our next session. It is my pleasure to welcome you back as we are eager to hear the thoughts and perspectives in the keynote address by Dr. Manmohan Kalgar, past president of ICI and technical advisor at Ultratech Cement. The session will be chaired by Dr. Putul Haldar, IIT Ropar, and co-chaired by Engineer Manoj Kavalkar, President-elect ICI. We extend a warm welcome to both of them. I will now hand over the mic to session chair, Dr. Putul Haldar, to begin the session. Now I invite Dr. Edi Shende to introduce Dr. Manmohan Kalgar. Edi Shende, sir.
Good afternoon. Good afternoon, one and all. It renders me an immense pleasure to introduce a renowned professional in the field of concrete, Dr. Manmohan Kalgal. Dr. Kalgal presently
इससे भी नहीं आ रहा सर, इससे भी नहीं आ रहा तो
It's rendered to introduce in the field of concrete, Dr. Manmohan Kalgal. Dr. Kalgal presently serving as a technical advisor and independent consultant. Dr. Kalgal holds a BA in civil engineering from Vishweshwarya Technological University and master in pre-stress concrete structures from Vishweshwarya College of Engineering. He obtained his PhD in concrete structures from the Indian Institute of Science, Bangalore. Dr. Kalkal has experience of 22 years in teaching research consultancy at MS Ramayana Institute of Technology, Bangalore. Since last 22 years, he is associated with Ultratech Cement Limited, contributing in the area of space concrete with BGR and in new product development and technical services. He has been actively involved in numerous professional bodies, having served as the Secretary General of the Association of Consulting Civil Engineers, past President of the Indian Concrete Institute, Vice President of both the Indian Association of Structural Engineers and Asian Concrete Federation. He currently holds the position of President of the Structural Engineers World Congress India. Dr. Kalgar has received numerous awards for his contribution, including the Eminent Engineer Award for the Institute of Engineers and Lifetime Achievement Award from the Indian Concrete Institute. We are privileged to have such an eminent person to deliver a keynote. Thank you, sir.
In addition to that, I will tell you in one line, he is the encyclopedia of the concrete.
next session में हम लोगों ने ये पार्टी लाने का सर
As the boss said, you have to do it. My job
So this session will be chaired by Dr. A.M. Badar, Vice Principal KDKC, and Dr. Ranjit Patil, Head CED PBCOE Nagpur. Let's extend a warm welcome to both of them. And I hand over the mic to session chair, Dr. A.M. Badar.
Can I start sharing?
Hello, sir.
Hello.
Simon Pitt, co-founder and head COO, International Asia and Pacific Denmark. I welcome you, sir, for today's keynote address. Now I request Professor Nikhade to have an introduction of Dr. Simon, sir.
Hello. Simon Klintberg is the co-founder and head of the COBOD International Asia Pacific Denmark. He is completed Master of Science in Engineering from the Technical University of Denmark, has more than 10 years of professional work experience in the additive manufacturing industry. He is the one of the original team members of COBOD International, and he is now heading the Asia Pacific market of COBOD. Over to you, sir, Simon, sir.
Thank you very much. I hope I'm audible. I'll share my screen. First of all, thank you very much for this opportunity to share a bit about Cobot and our product. And second of all, hope this will give you some insight into what we're doing at Cobot. Let me just do it like this. Okay. Is my screen visible and am I audible?
Yes, sir.
Fantastic. Great. Okay. So let me start. Today, I just want to give you a short overview of our technology, some of the houses around the world printed with construction 3D printing. And then I think one of the very important stages that we are in with 3D construction printing right now is how we bring this technology from the first movers and onto the mass market. So basically, how do we get this technology out in the field to do more works? And that I'll give you my insights on. And questions afterwards are very welcome. And I'll also share my LinkedIn profile and email so you can contact me after. So as a little teaser or starting here, I wanted to ask what the difference is between these two pictures in your mind. And the funny answer here is not much is different, right? So in this industry, of course, things has happened, but the industry of construction is looking a lot like it did many years ago. As we've seen a lot of other industries progress into automation, like production and agriculture and so on, we believe it's time for construction to do the same move. So that's what we are building technology for. Cobot is a company founded in 2017. We are just shy of 100 people with more than 20 nationalities around the world, multiples from India as well included in the team. We have more than 85 machines around the world with clients printing in all 6 continents where people are living. And we have 3 offices to help our clients in the best possible way. And one of them is in Malaysia. That's the closest to India, where we have technicians and architects helping our clients in the region, flying out if needed. So Cobot as a company, we are focused on the automation technology and 3D printers for construction, meaning that we are not builders ourselves. What we do is we enable our clients and partners to leverage 3D printing for construction sites. Therefore, we are very happy and lucky to work with world-class companies around the world. Can mention L&T in India as one of them. And they are really pioneering the efforts on bringing 3D construction printing into the construction markets in the local markets. So our core system is a gantry robotic 3D printer. So it is modular in the sense that you can build it up to the size that is needed for your projects. Every time it says Cobot here on the axis, it means that there's one module. They're 2.5 meters long, meaning that you can build up to the sizes that are needed. The x-axis max length on a standard system is around 12 to 15 meters. The length is infinite because you can add on more legs, and the height is here mentioned at 8 meters. But if you prolong the feet, we've actually seen that in India itself, L&T prolonged the feet, so they printed more than 10 meters tall and 3 stories with a system like this. So our approach to 3D printing is a little bit different from what you've seen maybe from some of our competitors in the industry, or co-workers, I should say. We focus a lot on the material parts needing to be as open as possible, because in every country, materials are different. In every region of a country, materials are different. And therefore, we cannot only import materials from very certain locations around the world to be able to 3D print. We need to be able to tap into the local infrastructure of construction materials. Therefore, we developed together with Cemex a solution where we can print standard concrete, meaning that we are using 99% locally sourced materials, some aggregates and sand from your local quarries, cement from your local cement provider. I believe we have clients that are printing with more than 30 to 40 different cement providers around the world. So it's not like it's tied to one specific one. You choose the brand of cement that fits your project the best. And then we have an additive set, the 1% down here, which is basically what makes that standard concrete printable, right? Because we need to make sure that we can pump it very well from the mixing until the printhead. And then at the printhead, we need to make sure that the material sets in a certain way so that we can layer them on top of each other, and so that the shape is retained as it's extruded. So, by doing this approach, you can see here, I think the important numbers of this slide is actually the bottommost one here, is the material cost per cubic meter. Because these prices are very, very close to standard concrete in the region. And if you are looking at the mortars that people are typically printing, you will be looking at 3 to 5 times more expensive than standard concrete. So in order to become commercially viable, we believe this is the right way to go. And it's reflected well in that 95% of the machines we're selling are with this concrete setup. However, I need to say that if you want to print with a dry mix mortar, you can also do that with our machines, as it's open in materials. Okay, so let me jump into a couple of projects to give you a little bit of a view around the world of different specific architectures and houses that has been built. We have this Beckham project in Germany, which is very unique from its futuristic and nice design. This house was completed as the first one Perry ever did, one of our both clients and implementers, but also shareholder. They have 6 of our machines printing in both the US and Europe. What's interesting here is to see the learning curve, right? As this is new technology, new teams need to learn how to operate it well. Took 36 days overall. The first ground floor was 28 days, and the top floor was only 8 days. These 2 floors have the same amount of concrete in them, so it's quite significant to see this kind of improvement just from the team. Today, with the newest technology, a house like this would probably be able to be finished within the 8 days total, because there's a lot of other upgrades that has happened in the last 5 years, and I'll show you some of these a bit later. Another project from Perry, also 3-story apartment building. I think what is very interesting and important to note here is that the German construction regulation is very, very strict. So just the fact that they are able to do these houses shows that 3D concrete printing is not just a tool for architectural elements, but it's actually already accepted in all the markets with the highest amount of regulation. So third project, here comes a little video. I hope it's not too laggy over the internet here. It's the biggest villa printed in Saudi Arabia. Saudi Arabia has been very, very active actually on this technology. This was the first one they did. Completed 340 square meters of house in 26 days. What's significant here is, of course, the size of the printer is very big, but also that they printed during night because the hot weather of the desert sun during the day does not apply well to concrete that's hardening. The house looks very fantastic today. There's a little video here of how it looks inside. They've done multiple villas after that now. This company is now printing for NEOM, the project in Saudi Arabia as well, a lot of houses. And they printed 5+ projects for the biggest oil company in the world, Aramco, as well. So very active with our technology and doing great. Now upgraded to having 2 machines. In the interest of time, I'll jump the video here. So the numbers we already spoke about. Also here you can see that the height of the print was significantly over the 8 meters I wrote in the beginning of the max. This is because, of course, they took concrete feet and elevated the structure on that. And you can very easily do that at first installation to unlock these kinds of sizes. And then when we speak about 3D printing, typically in plastics and metal, we speak a lot about the form freedom being the key component that makes 3D printing interesting, so we can consolidate parts and so on. I think SCG has done a great job, one of our clients as well. They developed their own materials and have printed multiple houses that are interesting. I'll show you one more in a moment. This one is a hospital. My headset just went out. Am I still audible? I believe I am. Yes, good. Okay, so this house was completed in 108 hours. It's 340 square meters big over 2 floors. But the interesting part here is really the form freedom that they applied in the design. So you can see some of the ripples here. Very form free and very nice design made. Another project. Jump to the next one. This one is a very unique house for a collector. So this house has been made so you can show all your collectibles in a very nice manner everywhere around the house. This is a time lapse of the actual printing. This house is in Texas in the US, and is more than 400 square meters big, 4,000 square feet. So very big. You can see some of the elements here. They really use the form freedom to make these interesting elements inside the house. All of these columns here will be lit inside, and there will be shelves with different collectible items. See it from here as well. And what's also significant is the very, very tall print here. It's 42 feet at the max height. And they did that by printing as far as they could on site, which is this level here. And then the rest they added as prefab 3D printed modules afterwards. Just to show you that it's not just houses that are 3D printed. I think actually one thing that we need to look a lot into here in the coming years is other application areas, because yes, well, we can all relate to houses because we live in them, but structures around the world are very diverse, and actually, if you look into the industry, there's an even bigger need for form freedom to solve different industrial problems. So, for example, water tanks is something we're looking a lot into, because we can print a water tank like the one you see here on the right in the matter of days. 2 days it takes to print something like this that can house 500 cubic meters of water. You can scale that up to almost any size you would like, and you print it directly on site. The beauty is that we can alter the thickness of the print while we go up, so we actually save material compared to standard technology. But also other use cases could be seawalls, bridges, service tunnels, manholes. And actually a lot of companies we're speaking to now are looking at energy infrastructure as well. So substations at energy plants is something that's very, very crucial to deliver in time. Otherwise, you cannot deliver electricity from that place. So these ones are something we're looking a lot into also targeting. And to give you another example of a very, very booming area at the moment is data centers, of course, due to all the AI needing a lot of computers. These computers need houses, and therefore I believe there was a saying from Microsoft that they need to deploy 1 new data center per day in the coming years, which is absolutely crazy numbers. This is just a small data center that was printed in Germany, also by Perry. It's 600 square meters, printed in 172 hours in total. It houses a very, very unique design that blends well in. This is an edge node, you could say. It's close to the client data center, only serving one client. As it's inside a city, it needed to be blending well in and have a nice architecture for the city, which it does well. Another, not industrial, but commercial building here is a cafe made by SCG in Thailand. A very form-free and unique design done by prefab. So they printed these elements in a warehouse and put together and painted afterwards. So here you can see some of the pictures from inside. This is operational. So if you're ever in Bangkok, you can visit this Ember Cafe. Okay. So let's jump to a very, very interesting topic here. So is how to take 3D printing to the next step, how to make it even more commercially viable. As we're seeing right now, we have a very new technology on our hands. Basically, the first commercial system started to come out 8 years ago, something like this. So what we have been in of stages at the moment is the early adopters and innovators, basically the tech enthusiasts. And now we've come to the point where we need to scale up the technology so we can prove the real world benefits in terms of ROI, so that the bigger construction companies start to take this in as not just a new novel technology, but the preferred way to construct their new projects. And once we're over that chasm, it's going to be very interesting to see the amount of growth in 3D printed houses. So in order to get there, in my opinion, we have to look at 4 different main topics here. One thing is how quickly can we output houses? because the quicker we can output a house, the quicker we can turn that house into an asset value and start earning money, which is interesting and important for whoever's building. And when we can do that, we can also do more projects with the same 3D printer that we have on hand. Second thing is how we localize materials to the greatest possible extent to lower the prices of the material and to ease up the supply chain, so it's a very easy way to print. And then what's very, very important now is that what we've seen mostly from 3D printing the last 8 years is proof of concepts in different regions and countries. And now we need to get the scale projects up and running, so the real world benefits can be seen once the machine is deployed to make 10, 20, 50, 100, 1,000 units and so on. And then, of course, the last thing is to have very reliable technology that lasts for a long time and is there to expand with the clients. So let's jump into the speed first. I think I addressed it a bit at the peri-print as well, but one very important thing is that the learning curve is a true thing, as it is with any new technology you are onboarding. So teams need to learn how to efficiently operate and plan around 3D printing because it is new. So this house in Borneo, you can see that that's the first one they made. The first 50% of the house they made in 10 days, and the second 50% of the house they made in 5 days. Corresponds well to what we saw in Germany as well, going from 36 days to 28 days to 8 days for ground floor and first floor on the Beckham house. The same we saw with our very own learning curve. We printed the first house in Europe in 2017. That's the one on the left here. This house had 20 tons of material, and it took us 2 months to print this. This was the first house in Europe, the first time we ever did it ourselves. Therefore, of course, a lot of learnings. 2 years later in 2019, and mind you, this is 6 years ago today, right? So we've developed even further. It took us only 28 hours, 3 days to print this same structure. Today, if we were to do it again, we believe we can halve this time, if not 1/3. So outputting a house like this in the matter of a single day. Another example of very quick print here is one of our clients in Saudi Arabia. No, sorry, in the Middle East, in Oman. You can see here they're only printing during night also because it's too hot in the desert. Or dry, I should say, is actually the most important point. They printed 3 structures, 3 houses in a matter of 8 days. And those 8 days are not just 8 printing days. Those are 8 days, including moving the machine 3 times. So quite significant achievement. And they are doing well today as well. Let's see here. So the only reason this house didn't complete in 1 day was because of the lintels, right? So that's a design question you could also ask yourself. Would you rather print all the way up and then leave the lintels for a dry material afterwards? Cool. And the way we are able to push the boundaries of productivity and thereby by speed is we are continuously looking at how can we output more material. So in the beginning, the far leftmost point here, this is also predominantly what the industry, the rest of the industry is doing today is very low layer height, approximately 1 to 2 centimeters of height, which looks quite good, but it's not very productive. Our standard today is 40 millimeters of layer height, where you double the output of material compared to the 2 centimeters. If you run a little bit wider nozzle for a bigger thickness of wall, you can actually run 50 millimeters with the standard today. But what we're seeing now, and this on the right here is one of our clients in the US, is pushing the boundaries not just a couple of centimeters more, but all the way up to 10 centimeters, 100 millimeters per layer. And this dramatically decreases the time to print a structure. This is a 5x improvement over the 2 centimeter, mind you, right? So this is very, very important when we speak about the asset getting handed over quickly, but also when you speak about the depreciation on the tool, the hardware, the 3D printer, that we can deploy it and use it for other projects even quicker. So very, very interesting development happening right these days. So it seems like today we can up the standards to 75 millimeters and 100 millimeters for specific materials, which is fantastic. Next thing is then, and a little bit correlated as well, you need the right materials, right? And how to make this more localized to reduce prices and ease up the supply chain. So here there's basically 3 realms, or two big main realms. There's the dry mix mortars, which is very easy to print. You only add water, but it's very, very expensive because the mix has been done in a bag where it has to be dried aggregates and so on. Or you can do concrete. You can do concrete in 2 different ways. Either you batch mix it on site, where you have very good control of the material. It's mixed right before consumption. But the problem there is that you need quite expensive mixing equipment on site to keep up with the output. And actually, even though you're trying to keep up with the output, now that we can do 100 millimeter layers, these outputs are not enough. We need to go up to 4 cubic meters an hour of concrete output. And therefore, the newest thing that we luckily have had a lot of great success with is printing directly from the industry supply chain. So from the RMC trucks driving around the cities. This is done with the same additives that we used before, just delivered directly to site from one of the industrial batch plants. This brings, I'll just show you a video where there's a bit of printing here. Actually, I have a better video in a second. This brings some very, very big benefits. One is you don't need to have expensive mixing equipment on site. You can rely on the professional batch plants in your area and region. Also, then this region's or the batch plant you're buying from becomes the certifying party of the material, meaning that you can, for each batch, get your quality numbers and quality assessment done directly from the batch plant. And the third part is that you can go to very, very big output because you can basically get unlimited delivery if you just time your trucks well, meaning that we can encompass this higher throughput of the higher layer heights. So here's a video of an actual house made with RMC truck concrete. This house was done in the matter of 8 days. It's 2 apartment buildings of 2 stories, so quite immense. Here you see the truck coming in, just dumping it into the truck, and here they are printing a 5 centimeter tall layer. Today, as you heard, we can do 10 centimeters, so you could actually halve the time for this house. So probably being able to make it in the matter of 4 days, but quite significant even the 8 days for the whole superstructure here. Let's let the video run a bit more. And one interesting comment on this project itself is that a lot of people are speaking about regulation and 3D printing, how to get these houses accepted. This house is done with an inner printed wall and an outer printed wall, and is actually corresponding to how we are building bricks. So the way this house got accepted in building codes is by the brick building code, the masonry building code, Eurocode 6. Which is quite important because that means that in Europe, you don't need to put in any reinforcement. We have no steel in this house. It's based on the masonry building codes, which further reduces time and cost. Cool. And then a very, very important factor right now is that our clients are going from smaller one-off proof of concepts to landing bigger orders on houses. This is very important because, as you saw, the learning curve is a real thing. So it's first once we've seen these 10, 20, 50, 100 houses printed that we can have the actual real target numbers that we can calculate the ROI based on. So a couple of big projects. Here's a 10-house project in Africa. Very well done, 1 week per house. Here is a student house project just starting this month in Denmark. It will be 36 units of houses that will be completed over this summer in 6 bigger units. They will be situated like this. And then I think a very, very big hands out to L&T, who's done a lot on the implementation of this technology the last 6 years. They have worked with our technologies in a lot of different sites around India, printing larger and larger projects. The last one being more than 4,000 square meters in one site with multiple printers. So that really pushes the boundaries and people's mindsets about what this technology can be used for. Good. And then lastly, if we look at the technology itself, just want to show a bit about what different types of machines we have. So the most of the ones you saw before is our core technology, which is the Bot 2. But based on the same system, the same brains, we've made a couple of other systems. We made if we jump all the way to the right, the Bot 3, which is basically a rail-mounted version of the same. This is very, very optimal when you do row housing. I have a small animation of that in a minute. So for larger scale projects where you have a lot of houses that are situated on the same straight street, it's a very optimal way to print. And then we have the Bot XL, which is the world's largest machines. We've delivered 3 of these to date. 2 of them have just been delivered this month in Qatar. The ones we've delivered there are of an x-axis of 30 meters width, 50 meters long, and 15 meters tall. These houses or these printers will print 2 schools in Doha, in Qatar, of 20,000 square meter each. So starting this summer. Very, very interesting. So here you see the XL. And here you see some of the mock-up tests of very tall printers. Here you see 23 meters in height, quite significant. And then one very, very important and feature to mention here is that now that we have these machines on site, we basically have a robot that encompasses the building site. We are not stopping at printing the walls. So we are building new tools to sit on the same system, robotic arms, casting heads, milling, painting, plastering tools, to be able to encompass and target more of the total construction of the objects, automating more of the construction site in essence. So here you see one of the first versions of a multi-tool machine that we delivered already 3-4 years ago to General Electric in the US. So this is a 2 x-axis machine. One x-axis here has the print head on it, and one x-axis has this big lifting crane tool, which I have a picture of here, that basically lifts rebar rings into the 3D print. So what GE is looking to print is windmill turbine towers, right? To unlock extra height of the turbines, they want to print the first 30 meters on site. So idea here is that we print 4 layers with the concrete 3D print head, and every 4 layers, a rebar ring will be lifted into the structure. Am I audible now?
Yes, sir. Yes, sir. You are audible.
Yeah, good. I think because no sound is coming back, my headset turns off every 10 minutes or so. Sorry for that inconvenience.
Actually, just all are mute the mic.
Okay, but now it's good, right?
Yes, yes.
Good, good. Okay, so this is the first example of a multi-tool printer, and this is to make the construction site even more efficient. So here's just a last animation of how the Bot 3 works. This is actually not just an animation. We have this machine in real life. We have it out on 7 sites around the world, has printed multiple houses. But this shows the idea. You print the first house. Meanwhile, you print the second house. You can move the tracks to the third plot, meaning that you have 0 downtime between the builds, which helps you in utilizing the 3D printer asset more, and thereby lowering the overall depreciation on a specific project. So this is very exciting new development, and it's already ongoing out there in the market. So as a last slide, I just want to say we have a very, very big customer focus. We are there with all our clients to get them started when they have questions and so on. We build up the success of this new industry together, also with our competitors, quite frankly. We need to show the construction market that this technology has a way on Earth, and we are very well on the way there. So with that, thank you very much for listening in. I hope this gave you a little bit of inspiration, and I'm very open to any questions you might have.
Yes.
The audio is very low, so if there's any questions, if you could repeat it, one of the ones inside the meeting, that would be very, very nice. Thank you.
Refers the construction from 1950 to 1924, 2024. It delivered about 3D printers. Those are the different buildings constructed by the Gola, Vermont, Denmark, Beckman project, Germany, Monolog project, Germany, hospital building at Ireland, building at Texas. So definitely due to 3D printing, scaffolding, picture, and all things are going to be get solved. And with new technologies, we are going to get. We complete the construction in first time. Sir also discussed about the making 3D commercially viable. How to make the project viable commercially viable. We discussed the parameters of stocking material hardware. Going from concept to stage the project. I got different ways of 3D printing services. Explain about the material capabilities. Ready for concrete. Seamless integration. Prefab materials. Thank you, sir, for a nice lecture. Going to enhance the knowledge of the author delegate about the confidential and that from our side to you, sir. Thank you.
We sincerely thank Dr. Burke for his valuable time and for sharing such inspiring keynote address with us. After this engaging session by Dr. Burke, we now move on to the next offline session. It is my pleasure to announce that we'll be hearing from Dr. Putul Haldar, IIT Ropar. This session will once again be graciously chaired by Dr. A.M. Badar with Dr. Ranjit Patil as a co-chair. I hand over the mic to Dr. A.M. Badar, sir, for future conduction. Introduction. Sir, the introduction will be given by Dr. Balbir Singh Rupra, sir. Sir, please carry on with the introduction.
Good afternoon to one and all. It's my honor to introduce our esteemed keynote speaker, Dr. Putul Haldar, Madam. Dr. Putul Haldar is a faculty in Civil Engineering Department at Indian Institute of Technology, Ropar. She has completed her PhD from Indian Institute of Technology, Roorkee, postgraduate structural dynamics in earthquake engineering from IIT Roorkee, and Bachelor of Engineering, Civil Engineering from Indian Institute of Engineering, Science and Technology, Shibpur. Her area of research is seismic evaluation and retrofitting of structure, non-linear modeling and analysis of structure, and performance-based design of structure. She has successfully handled many consultancy projects funded by Northwestern Railway Bhilwara, CPWD, Punjab Water Supply and Sewerage Division Moga, Greater Mohali Area Development Authority, Chandigarh, etc. She has contributed 16 journal articles, 11 conference proceedings in the reputed national and international journal and conferences, and one book chapter. She has delivered many expert talks on diverse topics in India and abroad. Thank you. Over to you, madam.
Yes. Yes. All these. That will be another exercise. Another thing I have that is microphone is there. So I have done visibility. It is visible, same as that of the. We have not compared with. Very close. So we have compared it with our sound insulation. Sound insulation. Sound insulation we are also doing, and we have shown to increase the impact by 2 and the panels and we want to paint it. And then some people were talking about material. If you paint with TI, that is that. Yeah, that is also what we are doing, that we are painting some piano material. This is the volatile material, is very, there is a vegetation. We convert volatile material to some great on slow and. So that's how you can simplify. It's a coating, basically titanium oxide. Many, but we are doing it on the surface, so that will absorb the mass of the light. That's the art of the. There are many things outside the internet. Very strong environmental, very strong chemistry background. So this is multidisciplinary. And that's the result, we take you are to be taught this chemistry, economics, and all these things. Because in a real project, you need American information of every field of. Whatever you are doing, enjoy it very passionately, and tomorrow is for you. Thank you.
Your lecture on next-gen particle work. Low cost, scientific panel got integrated and technically result smart number.
We,
One thing is clear, if the scope work for this area. I think
we sincerely thanks Dr. Putul Haldar for his valuable time and for sharing such inspiring keynote address. Thank you so much, ma'am. We express our sincere gratitude to Dr. A.M. Badar, our esteemed chair, and Dr. Ranjit Patil, our respected co-chair, for their valuable contributions during both the sessions. With this, we conclude the keynote addresses of day 1 of our conference. We now move on to the parallel offline paper presentation sessions, which will continue in the auditorium. All presenting authors are requested to remain present for their session. To all participants, we remind you that tomorrow's session will begin at 9 a.m. sharp, starting with the keynote address by Dr. V. Thombre, Vice President, ICI. We thank our online participants for joining us today. You may now leave the session. We look forward to welcoming you again tomorrow. Now I hand over the stage to the moderator, Professor M.